All right, Geo peeps, we are down to day number 5. Now, day 5 and day 6 and day 7 are going to have you attacking some material that you've never ever seen before. And this is going to be good for you because you just entered, dun dun dun, the Trig Zone. It's like being in the Twilight Zone, but it's going to be the Trig Zone. Okay, now what this basically means, and I know you've probably heard other people say that trig is like the hardest class they've ever taken in their life. You're going to get some basic information that's going to help you understand where trig basically comes from. Okay, now let me give you the short version of this. In the last 2 days, in day 3 and day 4, you have looked at some very specific triangles, specifically the 30, 60, 90 triangle, which ended up having short legs and long legs and hypotenuses, and came up with those relationships, where this was x, this was 2x, and this was x root 3. You've looked at that situation. You also looked on day 4 after a triangle that had 2 equal legs, had a 45-degree angle in it, and a 90, and would call the 45-90 triangle, and that was x and x root 2. Now, here's what my point is to talking about these 2 that you've already learned. This is only 2 triangles that you've ever learned. My question is, what about all the other ones? Okay, what I mean by the other ones are, what would you do in a situation when you had to do a 59-degree angle? Or what if it was a 44-degree angle? Well, those particular situations would not fit into these 2 criteria. They would have to fit in some other concept. Now, that other concept that they fit into is trig. This is what takes care of all the rest. Now, if you're going to learn anything out of this unit, you definitely want to learn your trig because it covers all the rest of the triangles. It does all of them, and it is the key to being good at doing all the rest of those kinds. Now, before you can even do trig in the first place, you have to actually understand this idea of perspective. I don't know if I could spell right. Perspective. Okay? Now, what I mean by perspective is if you really think about life, life is actually about a perspective. I have a perspective standing up in the front of the board and teaching you math versus you have a perspective sitting in your chair as a student and seeing math being taught to you. Okay, it's all about your perspective. Now, when we talk about trigonometry, we can only have 2 different perspective locations to stand. Say that this was a triangular room that you were assigned to stand in. I know, it's probably because you've been bad and you're a psychopath and they're going to put you in a triangular room just to drive you crazy. But what if you decided to stand in corner A and you decided to stand over here and decide to look at the triangular room from that perspective? Well, if you were standing over here, you would probably look at this wall over on the far side as being the wall that is completely opposite of your location. That's an opposite location is where it's at. It's not small leg or short leg or long leg. It's all going to be about where it is in relationship to you. So this would be called the opposite wall. The wall that would be across from the 90-degree door area, I guess, would always be related to being the hypotenuse. Now, it's really about what's this guy right next to you? And the word right next to you in geometry means that you're something that is connected to your location, or what we would refer to as adjacent to your location, ADJ. So this is from that perspective of standing in that corner, you would say, oh, that one over there is the opposite, this one is the adjacent to me, and that one's definitely the hypotenuse. But you're going to get bored standing in that particular spot. You're going to be like, I don't want to just stand right here. I would decide maybe I wanted to stand over in this spot on the other side. Now, the moment that you change your perspective on the situation, that side over there would no longer be called the adjacent, it would be called the opposite based on your perspective. Do you get what I'm saying? It's all about where you think you're standing from. Now, this one would, instead of being the opposite, it would be called the adjacent, and this one always turns out to be the hypotenuse because it's across from the 90. Now, these two spots in the acute angles, they're the only two places that you can stand in trig. You can only stand in the acute angles and decide whether or not you're an opposite or an adjacent. Now, the reason why you need to know these opposites and adjacents is because there's some trig ratios that you're going to need to learn on how to set up the right kind of question. And sign questions, you might have seen these on your calculator before. They usually are written as just sine, cosine, and tangent. They're either S-I-N, C-O-S, or T-A-N. If you don't have these on your calculator main screen, if you're using your phone, turn it sideways and you'll see them show up as what they are. These are the trig functions. And what sine does is it's equivalent to a relationship of two sides that are related to each other. And those two sides are called the opposite, and the hypotenuse are set up as a fraction like this. So if I was standing over here in A, I would put that this side, whatever its measurement is, would be over the top of whatever that measurement is if I wanted to use sine. Cosine uses a little different relationship. It uses the adjacent and the hypotenuse as a combination of two ideas. And the tangent uses the opposite over the adjacent. And it doesn't use the hypotenuse at all. Now, you're probably thinking, man, gee, how am I going to remember that? And there's a simple acronym that helps you remember this concept. And it's all about the first letters of everything in the ratios and the first letters of the sine, cosine, and tangent. And it is SOH, S-O-H, because it stands for sine is opposite and hypotenuse. See how it's sine is opposite and hypotenuse? And then it's CAH for C-A-H, that's cosine, is adjacent and hypotenuse. And TOA is the other one. Tangent is opposite and adjacent. It sounds kind of like an Eskimo word. Like, you know, if you like hit your foot on the edge of the actual bed and you like stubbed your actual foot, you would want to go SOH-CAH-TOA. You get it? It's a funny joke. Never mind. All right. Now, one of the other things that you're going to have to be concerned of when you do SOH-CAH-TOA questions is you might be asked about theta. Now, this is an actual Greek letter, the word theta. What it really stands for is angle, is what it actually stands for. So whenever we talk about any of these angles, we might not call it angle A, we might call it angle theta. That's just another name for saying, hey, this is the angle I want you to go and find, or the angle of your perspective. That's the key here. It's the angle of perspective. So keep in mind that everything is based on perspective. Everything in life is based on perspective. Now, here's what we're going to start out with here first. Number 1 and number 2, ask a couple of quick questions. It says, could you list the angles from the smallest angle to the largest angle? Now, understanding which is the smallest angle would have everything to do with across from the shortest side. If you had an angle that was across from a 5 and the other two were bigger, the smallest angle would definitely be angle A. Then the next largest angle would be angle C, and then the last angle that would be definitely the largest and always be the largest in a right triangle would be angle B because it's the hypotenuse. Now, that was pretty simple, just labeling something from smallest to largest. Now they're going to ask us in part B to figure out what the cosine is, COS, of angle A. Now, when they tell you what they want you to stand, they want you to stand at A. This is the perspective they want you to stand. So put a big dot right there so you know what you're standing in. And if I say cosine, I would think SOH-CAH-TOA, which is C-A-H for the CAH part, I would use a combination of the adjacent and the hypotenuse. Well, from this perspective, which one's the adjacent? This one is the adjacent one. That's opposite of you. That's on the other side. And the hypotenuse would be this combination. So the actual directions are saying, what's the ratio of cosine? And that would be 15 over 17. And it's just a fraction that you end up with, okay? Now, listing the angles from smallest to largest on this one would be kind of hard without any kind of numbers that are on it. But it could be possible to actually name what the tangent is. The tangent of angle M. Now, they want you to stand on M. You're like, oh, stand in this spot, okay? Now, if I stand in that spot, tangent is TOA, and we would use a combination of opposite and adjacent. So see, opposite and adjacent. So tangent of angle M would be the opposite. Ooh, that's this guy. He's the opposite. So that'd be M, little m. And the hypotenuse is definitely N. So it'd be M over N. And that'd be your relationship. Now, it doesn't always have to be numbers, but it could be letters just as easily as anything else. Now, since you've got the idea of what perspective means and what SOH-CAH-TOA means, you can easily come up with what the ratios are for each one. Now, the key here is to make sure that you know where you're standing. So if it says, hey, find me sine of S, put your big dot right here and tell me what you have around you. This would be the opposite, this would be the adjacent, and this would be the hypotenuse. Okay, because that's from that perspective. So sine asks for SO. So that'd be the opposite and the hypotenuse. What would that be? 5 and 13. Really? That's awesome. Cosine would be CAH. C-A-H. Cosine would be the adjacent and the hypotenuse, which would be 12 and 13. And tangent would be TOA. And TOA is an opposite and an adjacent combination, or 5 over 12. Now, if that's the idea from the S perspective, if we changed our perspective to a different location, like R, it would change the fractions. Now, what I want you to do is go back with your pencil and erase these names, just so you got it, and where S is. And now I'm going to change my perspective to angle R. And if I was standing in this location, now this one would become the opposite. This would be the adjacent, or next to me, and this one would be the hypotenuse. Now I'm going to pause the video for just a second, take a couple of seconds, fill out what sine and cosine and tangent you think they are, and then I'll reactivate the video and you can figure out if you've got it right. And voila! There you go. You've got your answers. Check to see if you got them right. So, meaning opposite and hypotenuse, opposite, hypotenuse, 12 13, so that looks good. Cosine, adjacent and hypotenuse, 5 13, and TOA, opposite over adjacent, right? Now, at this point in time, all you're trying to do is make sure, can you actually get the ratio correct? Now, you'll probably notice, too, this question says, are there any fractions that are exactly the same? Well, check it out. Sine of one perspective is the same as cosine in another, or sine in this one is the same as cosine in the other one. Tangent doesn't work that way. They flip each other is what they end up doing from different perspectives. Now, if they choose to use a theta key instead of using an actual letter for the angle name, who cares? They're just saying, stand over here. And if you stand over there, you'd be like, oh, that one is the opposite, and this one is the hypotenuse, and whoa, the adjacent is missing. You're like, uh-oh, the adjacent is gone. I don't know what it's supposed to be. Now, keep in mind, this is still a right triangle. It is still possible to use other kinds of things on it that you've learned in the past. For instance, Pythagorean Theorem still works. So 3 squared plus x squared equals 5 squared, And if I took 25 minus 9, I'd end up with x squared is equal to 16, or x is equal to 4. The adjacent side is 4, is how big it turns out to be. Now, if I wanted to set up the sine, the cosine, and the tangent from that location, it would be sine of theta is O and H, right? That's so. So it would be the opposite and the hypotenuse, 3 over 5. Cosine would be the adjacent, or CAH, the adjacent over the hypotenuse, or 4 over 5. Tangent is TOA, which is opposite over adjacent, which is 3 over 4. All right? Now, the key to this particular homework that you're going to see on day 5 is just about setting up your ratios. Make your big dot on your actual location. Label the sides what they should be labeled from that perspective, and then go get the numbers and put them in the right relationship based on SOH-CAH-TOA. All right, get used to it because you're going to do it a lot. All right, good job. 16 minutes. Woo, we're kicking it.